Hi everyone, I'm your friend Ram. So I hope you are doing good. So today we will discuss about our next question, which is also asked in the recent interviews. And the question is, let's understand the question first, and then we will think about the approach, which approach should we apply here. So the question is similar to the last questions. If you have not watched my last video, in that also I have discussed a similar question, but there I have applied the different approach, and this is slightly different than that question. So here I will apply the different approach. So the question is, find minimum steps to reach from source point, which is A comma B, to the destination point C comma D, right? And the rule is here, you can move from x comma y or a comma b to so here take x comma y to x plus y comma y. So this is one step you can take, or you can go the other way, is x comma x plus y. So this is the second rule. So this is the rule we have to follow while going from source to destination. So this is a simple question, right? So take your time, understand the question, then only start. If you have any doubt, right, in question, let that doubt be cleared before starting the before starting the solution, you can say, right? Just ask the interviewer uh, uh, about your doubt, whatever you have, right? And then let that clear that doubt, and then only start on the solution. So take a pause here, and then think about solution, uh, and then I'll start my solution, whatever I am thinking, and then we will discuss that.
3, 2, 1, go.
So here I am thinking, so I have just written the rule here, right? And I have taken here two scenarios. One is 2 comma 3 to the 12 comma 5, and the second one is 2 comma 3 to 12 comma 13. So this is the reachable, where we will be like we will be at the target, and then we will print how many steps we have to take. So minimum steps, right? Not the maximum. Minimum steps. What could be the minimum steps to reach this position, right? And then here we will say, no, we cannot reach at the target destination, so this is the wrong path, right? So the approach here, I'm thinking, in last video I have explained by backtracking only, right? Where we were going left, and then checking, then coming back, then right, and if that is not also, then coming back, right, then coming back, and then again right, like this. So there I have explained that approach. Here I will and that was the recursive. Here I will not go with the recursive, because recursive I have discussed in the last video. So if you have not watched that video, please go and watch that video, so that you get to know about that approach. So here I will apply the BFS, breadth first search approach, right? And here it would be iterative approach. So here for this, what we need a queue. So I have simply draw a queue here, and in this queue what we will do, we will create the node here, right? And then we will put this into the queue, and then we will iterate until the queue is empty, right? So now first what we will do, we will create the node here. So here let's start this one. So here what we will do, I'll create this node 2 comma 3. This is our source, and destination is 12 comma 5. So I'll keep this one into the queue. So here what I will do, let me write this one. So I'll put this inside queue, right? So this is inside queue now. Now I'll iterate till the queue is empty, right? So initially queue will be empty, so you have to keep in mind, initially queue will be empty, but after putting this one, inserting this into the queue, then we start the while loop, and then we'll say, if queue is empty, then only come out from the while loop, right? So here, so now what we will do, inside the while loop, we will take this out, right? I'll take this out here, and I'll take this out, and here, right, let me delete this one. Yeah, so I have taken this out, and here now I'll apply the rules here. So the first rule is, you can go x plus y comma y, right? So I'll create the separate node here, and then say, and that value would be, the next node would be this one, right? So this would be the, after applying the first rule. So yes, I have applied this rule, and then I will check, is this the less than or equals to the destination? Yeah, it is less than, but not equals to. So if it is equals to, then we will say, yeah, we have reached, but this is less than, right? So what we will do, I'll keep this inside the queue again, right? Q is empty now, so I'll put this inside. And then what I will do, I will apply the second rule here. So in the last approach, I was applying on the first rule first, right? And then coming back and then applying. Here I will apply the first rule and then second rule together only, right? So here I'll apply the second rule, and after applying the second rule, I will see this one, right? 2 comma 5. Are you, I hope you are getting. If you have watched that video, then it is very simple for you, this approach. So that's why I am insisting you to watch that video. Go into my playlist and watch that video, right? Last video. So this one, right? 2 comma 5. How 2 comma 5? So here x would be same, 2 comma 2, right? And then y would be y plus x. So y plus x, that is 5. 2 plus 3, that is 5. That's why I'm saying 2 comma 5. Now I'm putting this 2 comma 5 into the queue here, right? I have put it. Now coming back and on the top and say I'll take this out now, right? I'll take this one out. So let me delete this one, and I'll take this 2 comma 5 is out. So now we have done, okay, so we have done with this one, right? Now I'm checking with this one, right? So we are now currently at this place. So at 5 place, I'll apply the first rule here. So after applying the first rule, I will see 8 comma 3, right? 8 comma 3 is not equals to the destination. It is less than the destination. So we will apply on the, so we will, what we will do, we will put this one into the queue. So now what I will do, I will put into the queue this one, right? So we can say uh, after applying the first rule, it would be 8 comma 3, right? It would be 8 comma 3. So I'll put it into the queue here, right? So queue follows the first in first out rules, right? So pushing will happens from the back end, and popping happens from the front end side. I hope you know about this one, queue and stack and all those things. These are the basic data structures. If you don't know, just put your comment below the video. I'll make one video separately for your doubt, right? So now this one, so this one is applied. Now what we will do, we will apply for the second rule also here. So what we will do, we will apply the second rule here, this one together, right? And after applying the second rule, it will be 5 comma 8. 5 comma 8 is also here, yeah. So 5 comma 8, right? Now 8 is becoming more than the 5 here. See, this one is, or d is destination is 5, but here it is coming becoming 8. So now you have to keep in mind, now this node should not go inside the queue, because if we follow this route, then it is leading us to the wrong direction, right? We will never find the destination here if we follow this one, because here 8 is leading to the like it is greater than the destination y value, right? So this is wrong. So we will not do anything here, correct? Now what, so we are done with this 5 comma 3, right? This one we are done. So what I will do, I will delete this one, and I'll take one out from here from the queue. So I'll take this one out here, right? And so means we are at this place now. Now we are at where? We are at this place now, here. Now I'll apply here first rule. So after applying the first rule, I would, it would be 7 comma 5. 7 comma 5 is less than c comma d, that is 12 comma 5. Yes, it is less than this. So what I will do, I will insert it into the queue. So what I will do, I will insert this into the queue. So here I'll add this one, 7 comma 5, right? 7 comma 5. So I have added this one here, 7 comma 5. Now I'll go to the right, I'll apply the right rule here, and it would be 2 comma 7. 2 comma 7 is also going beyond this this or destination, 12 comma 5. So we will not do anything here, right? So what we will do, we will not do anything here, right? We will not put this point inside the queue, right? So now we have the queue, and now we are done with this 2 comma 5, right? 2 comma 5 is done. So what I will do, I will delete this one, right? And I'll take one out from the queue. Queue is not empty, that's why we are looping inside it. So I'll take this one out. So here I have taken 8 comma 3, right? So now we are at 8 comma 3. Now we are at this place, 8 comma 3, right? So here I will apply the first rule. So after applying the first rule, it would be 8 comma 11, right? X plus y, that is 11 comma 3, sorry. So this would be 11 comma 3, 11 comma 3 here, right? So 11 comma 3. So let me enter this one here, it would be 11 comma 3. Correct. I hope you know how it become 11 comma 3, because here we are applying the first rule here, x plus y comma y, right? X plus y, that is 11 comma y is 3. So this would be, so now this is also yeah, this is true, right? 11 is less than c, and 3 is less than this. So what we will do, we will put this inside the q. So what I will do, I'll put inside the q here, right? Let me move them out, sorry, in front, and so that it would be good. Yeah. So here it would be 11 comma 3 is inside the queue now, because this is correct, right? It comes in the range only. And then I'll apply the second rule, right? So we have applied this one. So now I'll apply the second rule here. So on the 8 comma 3. So 8 comma 3, after applying the second rule, it becomes 8 comma 11, right? It would be 8 comma 11. 11 is greater than the D destination value, the D, right? D is 5, C is 12. 12, this C is coming under the range, but D is going beyond that. So what we will do, we will not take this one, nothing, right? Now we are done with 8 comma 3 node. So what I will do, I will remove this one, I will delete this one, and I'll take another node from the queue. Queue is not empty, so I'll take the next one. So next is 7 comma 5. So now going at the 7 comma 5, right? So this is your 7 comma 5. So here I'll apply the first rule. So if I apply first rule here, then it would be 12 comma 5, right? It becomes 12 comma 5, right here. So it becomes here 12 comma 5 after applying the first rule. So now I'll check, yeah, this is the destination, or beyond the destination or below the destination. So yeah, this is the exact destination, C 12 comma 5. This is our destination, C 12 comma 5. Correct. So here we are getting 12 comma 5. So from here, what we will do, this is the destination we have reached, means we have reached at the destination. Now for steps, if we count the step, then see, here first we applied here one step, right? And then this is also one step. So to reach here and here, we need only one step, right? Then here we need two step, right? Here we were not going. From here, this, for reaching this one, this node, we need one step. From here, this one, two step only, right? Second step, here we are not going. And from here, this is the third step we are taking. So these three, or functions should be written three, right? And this is the approach we are thinking here. If you are thinking any different approach, where that could be more efficient than this, then let me know. Just put your comment below the video, and let other people know, and let all of us get benefited using your approach, right? So now I'm moving to the code section, where I'll implement this logic into the code. The code could be in C++, Java, or whatever language you know in that, because DSA is common for all the language. So I'm working on C++, so I'll implement this logic into the C++. So let's understand the code. So I have created one structure, right? And here I will store the x comma y value, and steps, the taken steps, how many steps we have taken. And then here I'm initializing these values using the structure constructor here, right? And then this would be our main function, minimum steps to reach the destination. Here I am taking input source a b, and destination d, c and d, right? So I am checking first, if the source is the destination, means source and destination are same, then let's return from here only and say 0 steps required, because we are currently at the destination only, right? I have taken here q, right? In the logic we have understand, right? We need a q, and in q we are putting the states, right? So here I am pushing the state. I am creating one state here, where the a comma b, and then steps taken is 0. So I am putting this, making this state, and then inserting it into the q, right? So I have explained you, right, here. So what we were doing, we were first inserting this first node inside the queue, right? And then we were I was saying we have to run the while loop in till the queue is empty. So that is what I am doing here. So I have inserted this first node inside the queue, and then I'll say if queue is not empty, then just going through it, right, while loop. So till queue is empty. So now queue.empty, I have put the logic here, and then I'll take this out from the queue. So this would be our first node here. This is the current node, right? I'll say current node. I'll pop this out from the queue, right? Uh, so you have to keep in mind, right? Queue.front, it will give me the front value, but it will not the front node from the queue. So for popping that out from the queue, what you have to do, you have to write this code here, q.pop. pop it. What it will do, it will remove that node from the queue, front of the queue, right? So I hope you know about queue and stacks, so let it be. So here what I'm doing, I'm taking the x value from this current node, y value, current dot y, and then steps, how many steps we have taken now. So now I'll apply the first rule here, and if x plus y is less than c and y is less than d, then only we will go inside this block, and here we will check if x plus y is equals to c and y is equals to d, means this is the destination we have reached. Then what we will do, we will return the steps, whatever steps we have taken till now, plus 1, right? And then we will return that value from here, right? And else if this is not the destination, and then what we will do, we will create the state of this using after applying the rule, and then we will put this into the queue again. So right, we are pushing here, q dot push we are applying here, right? And same logic we are doing for the second rule, where we are going, we are applying the second rule here. Second rule means this x comma x plus y, right? X comma x plus y we are applying here, and if x is less than c and x plus y is less than d, less than equals to d, then we will go inside and we will check for the destination. If this is not the destination, then what we are doing here, we are creating the state with this data and then putting this state into the or node into the queue, right? And then we are at the end of the while loop, so we will go back and check, yeah, queue is not empty, then again we will do the same thing here till queue is empty. Either queue is empty or we have reached the destination, because we have put here a return statement, right? So this is the thing. If queue is empty and we have not reached at the destination, then what we will do, we will return -1. -1 means no valid path. So I hope you got it. Let me run this one. So I'll build it, and let me run this one. So this is 0 to many steps to reach .exe. See, minimum steps required is 3, right? Here 3. So we have also calculated here 3, and we are getting 3 only. So now I have explained about the first use case here. You can try the second use case, where source is 2 comma 3 and destination is 12 comma 3. So this would not be reachable, so it should return -1 here. So I hope you understood the logic, you understood the code. So I hope you enjoyed the video. Press the like button and share this video with your friends, so that they can also be get benefited by watching this video. And put your valuable comments below the video, so that I'll include your valuable comments in the next upcoming videos. And yeah, see you next time. Till then, keep learning and keep exploring.